Now, what we want to do is look at angles that are not just restricted between 0 and 90 degrees. We've done that so far. Like all the angles we've looked at have been between 0 and 90. We've taken sine, cos and tan of those angles between 0 and 90 degrees. Now what we want to do is branch out from that. We want to go a little bit further because the angles we want to take are not just restricted between 0 and 90 degrees. So what we're going to do is use what we call the unit circle. Now it's called the unit circle because the hypotenuse is equal to 1. Now the hypotenuse is equal to 1 there, and in this triangle we're going to take the angle here. I'm trying to get it close to 45, but because of the little applet here doesn't allow me to, I can try to get it close to 45, but I'm not too far off. So imagine that's just 45 degrees, and if it's 45 degrees we know we'd have a nice isosceles triangle. So the two decimal places we can see that our opposite side's 0.71 and our adjacent side's 0.71. So for all in purposes, that's really 45 degrees as such, because our opposite and adjacent to two decimal places are the same. So that's good enough. Now notice our angles here, our ratios here. Cos of 45 degrees is saying 0.71. Well, why is that the case? Well, we know cos of 40 of the angle here would be the adjacent side, 0.71, over the hypotenuse, which is 1. Now the hypotenuse in our triangles is not going to change. Even if we move this around, we see our hypotenuse stays the same and our opposite and adjacent sides are changing. So, but if I've just got this angle close to 45, I'm going to have those two there. So adjacent side on our hypotenuse is 0.71, and sine of 45 degrees is 0.71 as well. So I could change that to go to 30 degrees, and I'd get close to the values we had before with our exact values. So I'm trying to get close to 30 degrees here. It's not as easy as it seems, but I'm getting 30.28 gives me the sine of that is 0.5, and that would be equivalent of root 3 on 2. So that's what we're looking at. We're trying to use the unit circle, and that's in the first, this is what we call the first quadrant, where angles are between 0 and 90 degrees. So as you notice, the angle gets closer and closer to 90, and we get up there and we're at 90 degrees right up the top. So we've got our angles there. You can see that the values on the side here, sine of 90 is 1 and cos of 90 is 0. It's that close that it rounds off to 0 and 1. But what I want to do is go into what we call the second quadrant. Now, what I want to do here is look at the situation of, what if I got that triangle that I had across there and put it across this side? So notice that the angle I've created here is 135 degrees. So that means the angle in this one would be 45, because that's 180 degrees to do the semicircle there. So there's 180 degrees all the way around. So if I'm going back 45 degrees from that, I'd have 135 degrees. Now, let's take note of our values. So notice here that we've gone to get to the point here, which is, again, 1 unit that way on the circle. That's why we call this unit circle. It's 1 unit radius. So we go up to this point there by going across and up. So we go across 0.71 and we go up 0.71, and that's giving us our 135 or 45 here. So what we've created is a congruent triangle to that one in the part over here. So because we've gone to the left of the origin, that means it'd be a negative x value and a positive, and we've gone up, so it's a positive y value. So cosine of 135, notice what it's giving us, 0.71, but a negative there. So what it's really doing is saying that cos of 135, the cosine of this angle, would be the same as cosine of 45 degrees in this triangle. So where the 135 basically is 180 minus 45. So we're considering this triangle, and that's where we're generating the angle, the ratio of 135. So basically we're saying, well, we're going to take a trig ratio of 135 degrees, because of the direction, the cosine will be positive, will be negative. But sine, if you look there, well, sine would be the opposite side, which is this side here, really. That's going to be up 0.71. So 0.71 over the 1, because we're considering that angle, would be the 0.71. So it's the same as what we had for sine of 45 degrees. So sine of 45 and sine of 135 are the same, and that's the same. That doesn't matter what angle we've got in the triangles. Look at everything in the second quadrant here is giving me a sine value that's positive and a cosine value that's negative. And that's because of this side being a negative side because we're gone to the left of the origin, and any angle that's greater than 90 degrees but less than 180 is going to the left of the origin there. So, and the sine value is still positive because it's above the origin. So that's why the sine values is positive. So all the sine ratios in the second quadrant are positive. What about if we go in the third quadrant? Now I'm moving it down here and try and get it close to what we had before. There we go, 225. Again, notice our values here, minus 0.71. Now sine's minus 0.71. Why is that? Well, we're still moved to the left of the origin, and we've gone around 225 degrees, but notice that would be 45 degrees there. If you notice the triangle we'd have here, that would be the same as the one we had there and the one we had in the first quadrant, except it's just in a different direction. Different direction because the x value is negative and so is the y value. So if you consider that, cos of 225 is negative, sine of 225 is negative. If you consider it as the tan of that angle though, tan of 45 would be the opposite side on the adjacent side, which would be the negative 0.71 over negative 0.71. That would give you a positive. So tan, all the tan values are positive here. Sine's negative, cos is negative, and tan's positive. So that's the relationship we have. Any angle between 180 and 270 degrees. Because once we go past 270 degrees and go into the what we call the fourth quadrant, we start to have a situation now where we're going to have the x values being positive, but the y values being negative. So if we look at the cosine, the adjacent side now is positive over the hypotenuse for this angle, which is 45 degrees away from 360, 315 degrees around. So 360, go back that 45. Again, a congruent triangle like the other three that we had. And so you can see that your cosine gives you a positive value, but your sine gives you a negative value because it's going to be the adjacent side here, which is going to be the same value as that one. So the opposite side here over the hypotenuse gives you the sine being negative because that's the opposite on the hypotenuse, that's the adjacent on the hypotenuse. So positive side on hypotenuse gives us a positive. So only the cosine values are positive there. Sine and tangent will be negative. So we haven't got the tangent values here, but you can see that the tangent would be the opposite over the adjacent, and because the opposite and adjacent are different signs, then it's going to be a negative. So that's what we're looking at when we start to talk about angles in the four quadrants, because what we want to do is be able to look at angles going anywhere between 0 and 360 degrees. So what we need to consider, in the first quadrant we have an angle. We're going to get an angle there that's going to be, and we label that theta. But in the other quadrants, we're going to consider that angle being the angle back to the x-axis. So whether it's there or whether it's there, and we're going to call this what I like to call the related angle, and I'll talk more about the related angle as we go through, because the related angle is going to be what would be the angle that's related to in the first quadrant. So in the second quadrant, we take that angle and we subtract it from 360, because we take an angle away from 180. That's going to give us somewhere between 90 degrees and 180 degrees. So that would be in the second quadrant, because that's 90 and that's 180 and that's 270, and we consider this as 0 and then 360 again when it goes back around the full revolution. So if we're in the third quadrant, we're going to 180 and then we're adding on that related angle. Remember, it's got a relationship to what we're going to see in the first quadrant. And then in the fourth quadrant, it would be 360 minus that angle back to the x-axis. So we're always going back to the x-axis. And that's where you're seeing this diagram get set it up. So there's our unit circle again. Okay, and you consider that as the point xy, like we had in our diagram when we were playing with the numbers. But if that's the case, this one's going to be minus xy. This one's be minus x minus y. And then this one would be x minus y. So you can get the values there that you will have all the time, and you're able to generate the positives and the negatives. They give you these situations. Now you can test these with numbers, but basically it was what we were looking at before. Even when we're in the first quadrant, well, they've pretty much laid out. We've done that between 0 and 90. But in the second quadrant, where we have sine of an angle, there that would give me something between the first and second, 90 and 180. We take the angle, or if we get that angle and relate it back to, say, like we said before, 135 would be 180 minus theta. That would give a sine of theta, because it's going to be the same. So sine of 135, the same as sine of 45. But cos of 135 would be cos of 180 minus 45, which is the same as minus cos of 45. So we, again, see how we relate it back to the first quadrant, but what sign are we going to get? So the negatives in the second quadrant, but only sine's positive. In the third quadrant, we get tan being the only one that's positive. The other two are negative. And in the fourth quadrant, we get sine and tan being negative, but cosine being the positive one. So that's what we're looking at when we look at the angles in the four quadrants. We want to break them back down to get the angle that goes back to the x-axis. So we have to manipulate it considering what quadrant we're in, and then we have to say, well, we're going to get a different sign in the second, third, and fourth quadrants, then depending on what quadrant we're in and what sides we have to consider as such. And that would give us our different ratios. So that's what we're looking at with the unit circle and angles in the four quadrants. So the next video will take that through a bit more and show you how to apply that to some actual numbers. So considering the quadrants and considering the signs we're going to get.